I extend a warm welcome to all the participants and our chief guest of today, Engineer Er.P.Kumar. So before handing over the session to him, I would like to introduce our chief guest today, Engineer Er.P.Kumar. He is a CEO and Director of VRM Energy Consultancy Private Limited, Chennai. He is a competent, positive attitude and energetic electrical and industrial engineer with 25 plus years of extensive experience in plant and machinery maintenance, troubleshooting, spare part management, EPC, supervision of new project execution, etc. He is experienced in design, detailed engineering, planning, DPR, and successful commissioning of solar grid-connected mega project and rooftop installation. He has done so many projects, he and his company. Project reports and projects he has done, solar power projects, feasibility studies for TNEB, TEDA, DTCP, MNRE, IREDA, and so many. He has given an extensive profile. So due to time constraint, I'm not giving all. He has close interaction with Moser, Tata BP, Reliance, Voltec, Excel, Canadian Solar, etc. Again, I'm mentioning only a few. Sir has given many things. I think during the presentation, sir can elaborate on his company and what he's doing, right? So he has got his own company and he has completed more than 50 plus projects, right, in India as well as worldwide. And I think we have got an excellent speaker here today, and it's a need of the hour also, and it is very useful for students. So I request all the students, please do not ask any question during the session. At the end, you can chat with sir or you can just unmute and ask him some doubts or whatever you have. Now I request all the participants to mute your audio as well as video. And let us start this session. Once again, I extend a warm welcome to Engineer Er.P.Kumar, who has readily accepted our invitation to come, that too on a Saturday in his busy schedule. And I invite him on behalf of Dr. MGR Educational Research Institute and first year B.Tech. So welcome, sir, and the stage is yours.
Yeah. So good morning, all. It's a wonderful opportunity given to me to enlighten the youngsters and to share my knowledge and experience to the upcoming our engineers. I hope it will be definitely useful to them. These engineers can choose solar energy as the main profession in the future. I hope at least 50% of the people turn to our field. I will be very happier. Yeah.
Sure.
First of all, let me just give a small brief about this engineering, solar engineering especially.
Yes.
Actually, yes, we all need electricity around the clock, 24/7. So electricity we have been using electricity produced by coal and oil and diesel, these kind of, and the natural gas. This is all our the old types of electricity generation from 1900s onwards. Okay. Now we reached one stage, and what happened around 15 to 20 years back, then this one of the renewable energy concept has come. So with that, so in renewable energy, what happened? The wind energy that plays a vital role. So wind. So in India, if you take our state is the leading wind energy player. Around 8,000 megawatts of windmills we are having in our state, which is the India's #1 in wind producer. But the issue in windmill is cannot able to give electricity round the clock or round the year. So whenever there is wind available, you will get the wind power. That also what happens, all of a sudden in one area, the wind power will be more. And actually we cannot able to utilize also 100% because the supply demand issues are there. So the production is not uniform. The utilization is also not uniform. Then what happened? The waste to electricity from the waste biomass, then these are all the renewable energy concept. Then what happened around 15 years back, there was an engineering that's across the globe. Okay, why don't you utilize the energy from the sun in a full-fledged way? Okay, that R&D and everything went on well in Europe and as well as in Japan and other countries. So with that, from sun, actually we are getting, actually the two types of energy we are getting. One is the light energy from sun. The light energy we are able to convert to electricity. The next energy is the heat energy from the sun. See, the heat to heat, like in the houses, you might in some apartment houses and in some hotels or industries, you might have seen on the above the roof, they are using for the water heater. The technology, so how it works is it converts the sun's the heat energy to the heat energy. So the heat is being transferred from one form to other form. It can be water. So this is one technology. This is also used in a lot of industries for regulating the pressure regulation of pressure maintenance, and also the temperature maintenance in some big, like in NLC and this kind of big industries. This is one form of utilizing the energy from the sun. The next form of utilizing the sun is to convert the light energy from the sun, which is available around the clock, it's available around the year, but with some limitation in the sense we can utilize 100% of the sun power from 8 to 5. And what happens before 8 o'clock? It will have the startup power. Then from 8 to 9, 10. So from actually 9 to 3, you will get 100% efficiency from the sun's radiation. Actually, it is the radiation level. After 3, it will start decreasing the power. Then at 5, 6 o'clock, that energy will get slowly it will stop. So this is the way. This is available almost 90. Even in the rainy season, see, actually that time the heat will not be there from the sun, but the light energy will be there. For that reason, we have installations across the India in Ooty and actually in remote hill areas also. It will work nicely. There is no problem. Okay. Now let me. So this is a small introduction about this engineering, and regarding the employment opportunities in this field, I will have a quick introduction about the employment opportunities in this field. Okay. In this engineering, we are installing the system in the roof. So what happened? We need engineers from civil engineering, then the structural engineering, and the architectural engineering to design the plant. So how the water flow will be there, in which angle we need to keep, and what is the wind speed. So how to work the wind speed. So the system which we are installing in the high-rise building, it should withstand the horrible the weathers also. Storm will be there, then rain, and so it should withstand at least 150 km/h speed. So how to design the system, in which angle it needs to be fitted. It is not like that simply you can go and fix the panel on the roof and it will start working. There is an engineering, there is a design engineering is involved. So the DC designers, DC means the direct current side, we need designers from that side. Then after the DC output, then it gets converted into AC. So we need the AC design engineers also. So to match the load, what is your requirement, how to fix the load and all. This is another type of engineering. So we need civil engineers, mechanical engineers, electrical engineers, electronic engineers. There is a plenty of opportunity for all the engineering guys in this field. So I am very happy to tell this field is now open up in India. There are lots of megawatt plants across the country is coming. So see, the next opportunity is after you install the plant, you again need engineers to look after the wind-up. What is wind-up? Operation maintenance. See, to running the plant means if you just leave like that, it cannot able to run. It needs some good engineer to look after the plant. Okay, how many units are coming, and if some inverter are getting tripped, and how to make it work again, and what are the issues coming, and how to make the efficiency of the system. So these are all the opportunities in solar which I am in. Okay, now I will just go to the presentation. So with that, at the end of the session, as I am told, if you have any doubt, you can just note it down. And at the end of the session, you can ask me, and it should be of like interactive. You have any doubt, you can ask me. And even after that also, my madam is having my number and all. If you have any doubts and other thing, you always call me. Okay, ma'am, now let me start the presentation.
Hello,
Sir,
sir.
you can start the presentation.
Hello.
Sir, you can start.
Yeah, madam, I'm starting the presentation.
Yeah. So request all to mute your audio and video, please.
Hello, is it visible? Presentation is okay? You can able to see it? Hello? Yeah, okay.
1 to 10. Yeah. Can you see the presentation?
Yes, ma'am. Yes, ma'am.
Yeah.
Yes, ma'am.
You are able to see. Yes.
Yeah. Actually, before that, I was discussing about the opportunities only. Now we have a big issue. Now, last 1.5 months, there was a big problem in this across the globe. We are all suffering from the virus issue. So, how this industry, how our energy sector industry will get affected, and how to recover from this. Maybe from next week onwards, we have to recover from this, and how to bring back the business into normal. Let me just start with the what are the issues we are facing and how to get rectified and how we embrace ourselves to handle these issues. Okay. Let me start with that. Abdul Kalam sir was saying, for the young engineers, you need to think differently. Like for any job, not only in this industry or in this field, while you are working, maybe in the future, maybe in some IT industry or some mechanical industry or civil, you may face a different kind of problem at different times. See, like one kind of issue, it may not repeat, it may be of entirely different nature, and we should not get upset about the issue, and we have to think in a different manner. We should have the guts to attack the problem and to find out the root cause of the problem and to resolve the issue. So the impossible things, we need to find out some solution to handle the problem. Okay, these are all a very few projects which is executed by me across the country. Actually, these are all installed on the ground level. Each is a different technology. One is CAGS, and another one is polycrystalline technology, monocrystalline technology. And you can see this output from the solar, which gets interconnected to our EB, our DISCOM. DISCOM means the distribution company. It gets stepped up to 11 kV or 110 kV, then it will get distributed to the power plant of the electricity department. So the one which you saw is of the larger plant. Now I am just showing these are all the smaller plant which can be installed above, like in your engineering college or the industry, small industries, schools. We can fit it in any kind of roof, like a normal roof or a plain, or even that asbestos roof, RCC sheet, anywhere. Depending upon the strength and availability of space, we will make a design and we will do all the installation. We have the design team. We will design an economic design and positioning of the system, get maximum output from the sun. These are all the things are there. You can just have a look into that. These are all some of our installation. Okay. Now this is our hardcore topic. Now let us start with one by one. The first raw material which is being used in our system is our solar panels are the main that constitutes nearly 60% of the project cost. So this is the heart of the system, you can see. And the main issues we are facing is the raw material which comes inside the panels, or see the wafer and the cell. Solar cells, see 80% of the cells and wafer we are depending upon the outside countries only. So we are not, and in India we have very few companies, Adani and the Tata, Vikram, they only make the cells and wafer, but it is not enough to meet our Indian demand of 100%. So 80% we are importing from other countries. From Europe also we are importing, from Eastern countries we are importing, but Chinese, the reason why I am putting is the rates are very low. It is also meeting the European standard. So while we are importing the raw material, we have to see both the rate of the system and as well as it should meet the international standards. Then its availability and other things. Okay. So these are the issue. So in 80% we have the opportunity to produce the cells and the wafers in India. But what are the issues in that means? Because it is not an easy job, we cannot simply start immediately manufacturing the cells and other things. So the R&D setup that should be set up along with the industries. Then policy of the government, they should encourage, because when we start new, the rate will be more. So how to match this price, but without compromising on the standards. So these two are very important. So the engineering institutions like IIT and NIT and big institutions, they also should join hands with the laboratories to upskill the technical skill. This is the main important. Now at present we are only importing the cells and wafer. We are assembling it and we are putting made in India and we are just using it. But actually the inner item, the hot core items, we are yeah. For any doubt, you can call me, you can note it down and you can give a message maybe by the end of it. Okay. Then the inverters. This is the heart of the system, what you can say. See, the output from the panels is DC voltage. So how to convert the DC power into AC power? That is called the inverter. In inverter, actually, two types are there. The right side one, blue color one, are called string inverters, which is designed for IP65. IP65 means it doesn't need any external enclosure. Just like that, you can just fix it on the outer space. It will withstand any rain, any harsh environment, anything. So these inverters are one type of inverters. The next inverter is our ABB type inverters or central inverters. That is a very big inverter, half megawatt, 1 megawatt, 5 megawatt inverter. This needs an air conditioning system, then the heat exhaust system, HVAC system. We need to make a proper ventilation and other things. So these two types of inverters are there. So these inverters, the next question is, these inverters are called the grid-tied inverters. This 100% we depend upon outside countries, the Europe, the US, Japan. In India, no Indian company is manufacturing these intelligent inverters. In India, we have a lot of UPS and inverter companies, which they are making, like for example, Luminous, Console, Microtech, Sucom, and other few companies, like Emerson. These kind of inverters on UPS are there. This is not an intelligent inverter. Okay, what is the difference between this in that existing inverters which we are using at for the domestic purpose, hospitals and other thing? See, when the electricity goes off, that UPS or inverter gives the power. No, that's all the normal inverters. These inverters are called grid-tied intelligent inverters. Okay, what is the difference? This works with the grid. This takes the reference power RYB from the grid supply. This gets synchronized with electricity supply and it is working. So, so now the opportunity is we have to link with some companies to start manufacturing in India. Already some companies are already started and it is under testing. So slowly, so hopefully maybe within 6 months, these inverters we will also start manufacturing from India. ABB is already there in India, but other companies also coming. But what are the main issues is actually the technology. That there is a technology called IGBT-based technology that is the one which detecting the grid and our requirement. So that one we are yet to make this one. Like I already told, premier institutions and other things, they should have to spend more time and money. Then also there's some encouragement from central government for setting up the R&D laboratories. Only it can able to make. So until now, we have to now we are depending upon foreign countries only. So hopefully, in another 6 months, we will also start making in India. This is a very good opportunity. And shifting of the companies also from Hong Kong and other things, now they are shifting to India. This is a very good sign. So this is an opportunity we should utilize these things. Then our EPCM. Okay, what is EPCM? These two are the main system. Then other things we have all other like that, like what do you call that? Our evacuation system and the double pole switchyard, energy meters. These are all the things that are available in India. We make ourselves like L&T and other companies are manufacturing all the item Havels. These are all the big companies are there. We make everything in India. Only those two items are not available in India. That also we are working on. This is an opportunity. Okay. Then comes what is EPCM? Engineering, procurement. Then at the site, you have to build the site. Then you have to look after the site. This is called EPCM. In this, you need to make the DPR. DPR means detailed project report. Okay. What is the revenue? So how many number of years? What is the return on investment? What is the IRR? What is the debt service commercial ratio? So how much debt the investor has to put? So how from where he will get the how much equity he has to put and the debt from which bank he should arrange. So these are all the issues are there. What is the efficiency of the system? How we are going to measure the performance of the plant and how to ensure the return back, okay, of the systems and all of that. Then I am just showing some of the pictures at the site. There are opportunities for the young people. See, this kind of job, skilled manpower is required to install the systems, panel fixing and the DC cabling, then AC cabling, then installation of inverters, programming the inverters. These are all very good opportunities are there in this field. This is called supervisory control automation and the data acquisition system. With this system, the advantage of the system is you can watch your performance of the plant across the globe in your phone or in your laptop, anywhere in the globe. Okay, what time your systems are getting energized and how it is working, how many units you are producing. If your system gets tripped or something like that, immediately you will get a notification. So the engine is again the job of an IT engineer comes into the picture. So he has to make a program and other things as per the site requirement. Each site is unique. Each site, each plant is a unique experience. So as per the requirement of the end client, you have to design the system or modify the software. And this again is an opportunity is there. Yeah. In installation, what are all the hurdles and how we are facing the problem. Now the real work at the site. Actually, the labor, most of the laborers are not available. Now they all gone back. The north side people have gone back, and the engineers also. We have engineers from other parts of Madras. They all gone back. So it may take some time for them to return back and other things. So in this time, the youngsters, the young engineers at the site, that near to the site, who are not getting a job or who are into some other field, it is a good opportunity for them to come and learn the work and they can start up the job. Then logistics. This all our raw materials for the plant and the equipment and the machineries, it has to be shifted from Mumbai, from Gujarat, from airports, from shipping yard, from our godown, from warehouse to the individual sites. So that loading, unloading, the logistics, that itself is a big job. So that overheads now it's more because of this one. No? Now 1 more month also is stopped. So these are all some issues are there. Then the laborers. Now almost 90% the laborers are not available. So we have to utilize the local people, the local villages, because our site is in different areas, villages. So it gives an opportunity for the local villager to get his income. So instead of depending upon some other people. So these are all some of the new. But my issue is after this one finish, then the rainy season will come. In rainy season, we cannot do any external job. Only we can do the internal job. So this will all increase the cost and the number of days to execute the. Before, if only 100 days there, now it will go to 120 days or 130 days on there. Now because of that, the LD. LD means liquidity, the damages. And what is LD? If suppose you agree to do one work in n number of days, you are not able to finish your job within the days, every extra day in your agreed money, suppose you agree for 1 lakh means every one extra day, they will deduct 1,000 rupees from you. Like it's an example, if you don't go for this one. So how many days you are making late in executing the project, there will be LD, penalty, fine will be there. So you have to handle all these things. So then it's ultimately what will happen, the rate of the project cost will go up, and because of these issues, so we have to find out how to meet these additional expenses. This I am just showing you in one of our site how we are doing. We are doing the evacuation with a high voltage. Okay, you can see the left hand side. It is written LT panel. See the output from the inverter or low tension. Okay, which gets interconnected with the LT panel. Then comes the step-up transformer. That low tension is getting stepped up to the 11 kV or whichever voltage level in that substation. Then comes the HT panel. HT means high tension panel. After the high tension panel, it will enter into your revenue meter, ETPT, then your double pole structure, then your EB switch yard, then the customer switch yard. Then it will get evacuated to the grid. Maybe you can because this looks very simple and easy also. This what happened, every month you need to take the reading for your energy consumption, so that your revenue billing, how much money you will get from the plant, that will be getting recorded into the. Then also the tripping feeders are there. So whether it get tripped, the line, we have to watch the line. Okay, how much whether the voltage level is good or any phase problem, phase sequence, the trips, supervision relays, ETPTs, everything are there in this. Then these are some of our installations in some industries. For some of the food industries, there is on the roof itself. On the roof itself, we will install the plant. It will get interconnected into the LT system only. No need to go for HT system. The smaller capacity can be directly connected to your LT panel. You don't need to step up to the HT panel. This is about me. Then these are all our customer list. I can just give Adani, then Renew Power, then Hero Future, then the Tata Power, our newspaper, then the Repsol, then for the this one for the Government of India, say military, then Race Power. These are all some of the client list. I must quote from Alva Edison that he told one time he will invest all his money in the sun and solar. This is there is a day he's anticipating a day will come when oil and coal will run out. So before that, we need to get ready with our solar power. Okay, with that I am finishing the presentation. Yeah. Now, anybody have any doubt or something like that, you can ask me. Then if you want, I have one more presentation also. No, first, if you have any doubt in this, you can ask me. Then I can show you for the pumping system, for the water pump, how we are using water from the side.
Yes, if you have if you have any doubts,
Yes.
you can ask, or you can put it in the chat box so that I can ask, sir.
That's fine. That's
Yeah, that was a very valuable session, sir. I think students now you would have known what is the opportunity available there.
Yeah. We also need young engineers for our company. Also, we have around 40 engineers in our company who are working across India, civil designers, and architect, DC designer, and erection engineers. They are all loving their job. They enjoy the work with us. And actually working with outstation, it gives you a lot of experience also. Now we are doing a project in Vaishag, it's near the port. The working there itself is a very good enjoyment. Like the job will be there for 4 to 5 months. So you can, at one time you can enjoy the work. The rest of the time, each time you are getting an opportunity to see a new place, to visit to the new environment. See, what means weekends you can go around, you can visit the port, you can see a lot of things. So like that, this field is giving you an experience like you don't know the next site will be in Hyderabad or in Mumbai. Wherever there is a requirement is there, you can go with your team, you can do the good installation, you can have a good experience and you can come back. Then the O&M also, the operation maintenance.
Okay.
Madam, now I have one more presentation.
Yeah, there are few questions, sir. One from Shivaraj. What are the parameters that affect actual generation?
Good, madam. I will. Okay.
Yeah.
Parameters.
One more, sir. How will India increase power in industry in limited time? And one more question is there. Is it possible to send the power generated directly to the end user without sending into grid?
Yeah. Madam, that industry and all I have shown, now we have installed a plant for Hyundai on above the Hyundai. For whatever electricity produced from the grid, if you just connect it to the LT panel, LT low tension, it will go without the grid. Suppose you produce 1 megawatt from your grid by LT, you get interconnected to your LT supply. You don't need to use the grid supply. See, why we are using grid means, suppose you are installing a plant in Nagarkoil and you are utilizing the energy in Iringattukottai factory. Suppose your factory in Iringattukottai and your plant is at Nagarkoil. So you need to utilize the grid supply. For that, still like a windmill. You have windmill in different area and the actual user is different. So like that places, we are actually utilizing the grid facility from the distribution company. That is the reason. Next question is 1 minute.
Can we supply, that is, can we have the production in a limited time? Maybe I think he's asking after this COVID.
After COVID.
Is over, yeah.
Good. Actually here, See the installation time of the project completion. You can say around 100 days to complete a 1 megawatt project. Now, after COVID, now everybody is having stock. Before, the reason for 100 days is then we need to order the material, it has to come. Now in last couple of months, there was no any utilization. Our stocks are full. So whatever stock we are having, all the materials, it can be installed very fast. So the 100 days can be reduced to 50 days. Provided the labor, because the design is, see in this industry, again I am telling, the design is very easy. It's very simple design, the DC design, AC design, calculations are very, very simple. It is not, it doesn't involve much complex like the nuclear plant or other, even windmill also have some complex engineering, but this engineering is very simple. For example, I am telling you, if you want for your house 1 kilowatt system, what do you need? What you need is 250 watt panel into 4 numbers. That's all. Then one kilowatt inverter. That's all. Then one intelligent system. Very simple. So this is a small example I am telling. Like that you can just for 1 megawatt means okay, 250 into how many number of panel, then how many inverter, then what is the DC current, then how much DC voltage is coming, how to group in, how to go do the step up, in which level we need to do the step up. Like that only, madam. It's very simple calculation. Then other thing, then the main enemy of our solar, the parameter which is affecting is, see the heat, our enemy. When the degree, when the ambient temperature goes above 50 degree, we are losing 1% of our electricity, of our production we are losing. So, for that reason, in Europe they are using a different technology. In Russian countries they are using different technology. Indian technology is entirely different. We are using polycrystalline. This technology, Econ. This is well suitable for Indian climate and Indian weather. There they are using CIGS technology is there, CDGS technology is there. Like in Europe countries, where actually the weather, we have to, they design the system based on the low radiation with less temperature. Whereas in India, we are going up to 50-55 degrees or there. So we have to design, we have to redesign the system as per our requirement. That's all. And there's absolutely no problem. Yeah.
Okay. Yeah, one more question we'll take there and we'll move on to the next presentation. Kanagavalli has asked, is solar panel can work only with natural sunlight because artificial source like incandescent light mimics sun spectrum at a lower rate?
Yeah, excellent, man. Actually, if you see, no, okay. Normally, there are laboratories are available. With UL lab, CPRA labs are available. These laboratories, what we are using, like these laboratories, okay, what we are doing is, for example, our panel, 250 watt peak panel. And what is this wattage means? At 1000 at standard operating procedure time, standard operating procedure, that panel can able to produce this much wattage. That is the this one. In these laboratories, what they are doing is they will give only this artificial light and they produce the electricity. Then they will check whether with that degree, with that ambient, able to produce 2 watts or not. So, and what we are getting in natural is getting compared from the laboratories by using these incandescent lamps only. Yeah. Yeah, how it's getting generated by any weather, rain, sun, wind, anything is absolutely no problem. Anytime you will get electricity from the sun, but only that volume will be less. See, normally for 1 kilowatt, 4 to 5 units a day. If there is a very rain and weather is bad, you will get a lesser generation. That's all.
Okay. Okay, sir. I think we'll move on to the next. Yeah.
Very good. Now I will just go to the. Yeah, this presentation is about for the from solar water pumping system. See, like in India, there are a lot of remote villages are there across the country where still the EB grid power hasn't reached. So just imagine how these villages or the local people who are living there and how they can able to get the water from this underground when there is when there is a rainy season or some rivers are there, when there is issue is there, when there is no rain, when they need normal water, from where they will get this one. So the remedy for this, this remedy is not only for the remote villages or something like that. This can be installed. This we are installing in all the places, whether you have even in Andhra's heart of the system, heart of the city, we have a lot of installations. 1 minute, I will just show you this is a water pump. This works independently. Solar water pump, 100% work independent. This doesn't need anybody to go switch on and switch off the morning or evening, or this doesn't need EB power. Okay, the early morning it will come EB power, nothing. As long as you getting the sun, it will start work from 6:37. It will start work. It will work up to evening. So how many liters per day is our design? Then you should have some tanks to keep your water filled and can use for the other purpose. I'll just give you the purpose. Yeah. What are all the things you need to work out means water availability, how many feet down. Then you should know the exact this one, like 100 feet, the 200 feet, or 800 feet, or 1000 feet. Okay. Based on that, we need to design the solar water pump and motor as per the requirement. Then come as per the design of the pump, you have to design the panel. Okay, how many numbers are required? The DC capacity. Then after the DC capacity, we have the VFD. See, the variable frequency drive. See, depending upon the radiation of the sun, the VFD will work, and it will continuously tap the water from underground to outside without any stoppage. When there is no sun, you will get very little water. When there is high sun, you will get full capacity of water.
Sir, your presentation is not visible, sir.
It's not come?
PPT is not there.
1 minute. Madam, it's okay now coming?
Let me check, sir.
Hello?
Yeah, let me check 1 second. Yeah, now it's coming. Yes.
Okay.
Yes, sir.
Okay. I hope everybody can see the presentation now. Sorry, maybe. Okay, now it's okay?
Yes, sir. Yes.
Yeah. So now I will start again with this screen. This have any doubt in this? So let us make it as an interactive session. This screen you can see in the presentation. If anybody have any doubt, you can ask me directly. like anyone want to install this kind of system for their house or for their farmhouse or for any industry, this is a one-time installation. This doesn't need every monthly maintenance or annual maintenance or any fee you have to pay to the government, nothing. It is like an RO, like the RO plant in house, but in house RO plant you need electricity supply. But here is nothing. It's a one-time installation. Raw material is free. Any doubt? Yeah, you have to see the level. You have to see how many feet are, 100 feet or 200 feet. Based on that, we need to design the water pump and how many LPDs are required, liters per day, and what is your requirement. Based on your requirement, we will design the system. The VFD is there, the variable frequency drive. We have installed around 8,000 numbers in Andhra Pradesh. Across Andhra, we have a lot of installations. In our state also, around 1,000 water pumps we have installed. These are all good system. It's like a one-time installation. This doesn't need much. This only comes, any issue comes, maybe like once in a while, it gets stuck, pump will get stuck, or the water, the sludge will come. So you need to just remove the pump and to clean it and again insert it back. Okay, let me go to the next slide.
Somebody is asking what will be the cost for installing this.
Excellent. 1 HP. It was 1 HP equivalent to 1 lakh was the cost some 8 years back. Then what happened? Our central government has given 50% subsidy of the farmers. They give 50,000 and the end user give 50,000. Now 70,000 rupees per HP. That is the cost per HP. Okay, now let me go to the next slide. Next slide.
Yes.
Yeah. This is the bill of material and the design. You have to design and what kind of panel you need and what is the capacity of the panel, warranty and other terms, and what VFD you are going to use and how to do the programming. And the VFD should be of outdoor VFD first. Then in what happened in some villages, they have already EV supply is there, and also we can install. We can fix a switch. First, it will take from solar. If the solar fails or if there is a rain or if it not come, then it should take from the like that. Also, we can do the system. Then the 2 HP, 3 HP, 5 HP, 7.5, 10 HP, depending upon the requirement, we have to design the system. Foundation. We should withstand the wind speed of at least 150 km per hour, because these are all the remote areas where wind speed will be more. So we cannot simply just like that put the solar and come back. So design and the installation should be perfect. Foundation, the structures has to be designed as per that. Any doubt in the bill of material? Anybody? Okay. Now let me go to the next one.
Yeah.
Yes, you can see a real-time installation. This we have done last month in one of the site. It's a 2 HP pump. Foundation should be done. Then the VFD is there. Structures, panel. It's very simple. It's very easy. Programming has to be done at the VFD. Like the what time it should start and what time it should stop. It's a one-time programming. Then after the water, then you can fix a tank, water tank, or the root, or whichever way. That is all your. The place is 300 feet depth. See the water flow also you can see. It is not as it will not stop. It will come very fluently. Many people may be having doubt. See, from the sun we are getting the water pump. It may come like intermittent or whatever it is. Maybe some obstruction. It is a very normal only. But pressure will be more in a normal pump. This you can see the pressure will be slightly less, but ultimately what you need the volume of water, no? Then afterward you need to make a system to put it in your field. Okay. These are all our list of client. Yeah. Now you can ask me any doubts in the pump and as well as rooftop solar or other thing. We have 5 minutes left. Or my email ID, number, everything is there with madam. You can contact me for any requirement. I'll be happy to. I hope you people enjoy this one and you get some knowledge at least today from me. Is it right or?
Yes. So one question is that in today's time, which is the most efficient solar panel available in India?
Hello?
Sir, one question is there. Hello?
Yeah. Please,
in today's scenario, which is the most efficient solar panel? And student has asked.
Honey, only green. A lot of companies are there. So many companies are there.
Yeah.
You cannot simply see which company name. You can see MNRE. MNRE means Ministry of New and Renewable Energy. They gave the guidelines like what do you call ISI standards are there. If a company is approved by MNRE, means they are meeting the standards. That's all.
Okay. Okay, so I think there are no more questions. Anybody would like to tell anything? You can unmute.
Why farmers? Yeah. No, madam. One important, one good question.
Yes,
Mr. Singh has asked. If such good advantage is available by solar pumping system, why farmers are not aware and why they are? Yeah. This question I will give a good reply. See, in Andhra, when we went some couple of years back for the installation, what happened? See, this again, central government will make a scheme. Central government will make a scheme and they will give it to each state. It is up to the state government to implement, to utilize the central government. Central government has given a scheme. Okay, we will give you. See, the system cost is 5 lakhs. Okay, the system cost is 5 lakhs. The farmer will pay 1 lakh. Okay. Central government will give 2 lakhs. State has to take 2 lakhs. So which state is actively taking? Which state government is very constructively cooperating, constructively taking the advantage of the schemes and other things? They are well utilized. In the Vaishag, in Andhra, yes, Vijayawada. Yes, Vijayawada district, we have installed nearly 500 homes. Water level is only just around 10-50 feet, not even 50. Up to 50 feet, the water is coming like any this one. Farmers are enjoying the schemes. They are all readily, they are all going to the agriculture department and they are registering. And then what happened? Then they are just like that releasing order. Okay, go install. But these kind of schemes are available for across the India. It is up to the like Andhra, like other state government also. They should have to propagate. They should give support to the schemes, and they have to utilize this opportunity. Yeah, and another this one is our state. What happened? Free electricity was there. Maybe you know. For the water pump, free electricity was available. It will come maybe in the night time 1 to 3 or early morning 6 to 7. So these people, they don't want to even invest that 1 lakh rupees. They are getting when they are getting the electricity for even a couple of hours, they are getting water free. Then why they want to spend that money for the water pump? This is another issue. So this depends upon a lot of factors. Yeah. Why is pump inlet is 1 minute? Pump inlet is bigger than this outlet. Yeah. Actually, we need to see what is the bore size. Pump size. Pump dia. Then what is the HDPE? It is not a normal pipe. You cannot simply put it in the coupling of the pump. It's a heavy duty pipe. So what happened? Normally the size of the bore is very big, around 8 inch or 8 to 10 inch maybe. So we need to get all the inputs before, and we have to design the system and to do the installation. Yeah. If the system is the weather dependent, no, it will work for any climate, anywhere, any this one. Absolutely no issue. Yeah. No, rainy days you don't need the water pump. No, you can switch off the pump. So natural water. How many water pumping are in lakhs? Stations are there across the country, and in Andhra we have installed the systems are called auto rotation type. Auto rotation means the panel will rotate from east to west. It will capture the sun's rays from the sun's movement from east to west. Then again in the evening, it will again return to the normal mode. It will go along with sun to get optimum energy. Okay. What is the count of pump place? Yeah, in our state also we have a lot of more than lakhs. I don't have the exact this one. There is a department called AED department is there. AED in the Nandanam. Maybe they are the right people to give you the exact information. This is called agricultural energy. This is agricultural engineering department. Yeah. Yes. Power supplied, fulfilled through solar energy for all the purpose. It is fantastic. There is absolutely no issue. It is all working fine. Yeah, madam. I think.
Yes, sir.
You got all this one. No? Presentations, I can share it, or even the recording is there.
Yes,
you can share it to other people. Those who are not able to and let them get some more knowledge.
Yeah.
Okay.
Yeah.
And once again, I really, madam, it's a very good opportunity. I have enlightened, I have had my experience. Another thing, it is a good. At least if some 50% of the people come to my field, solar, because we also need a lot of engineers. I have to get more people for my team to get them into the work. This is a good sign. Let them get the knowledge about this industry also.
Sure. I think they would have got some insight of what it is, because we have been talking about what is that, but still I think today you have given a very good overall view of what is that industry and why they need engineers. Even we all think or panel vecha mudinju pochu appadina, but now today you have explained exactly what is the need. So I think this is really need of that. So on behalf of first year B.Tech Dr. MGR Education Research Institute, I thank you, sir. Thank you for spending your valuable time and educating our students.
Thank you, madam. Thank you.
And hope that we can have more such interactions in the future. We can also have after the lockdown. I'll try to bring sir live. Maybe we can have some other collaboration or something, sir. So I think the students need somebody like you to guide them and mentor them. Because nowadays we talk about outcome-based education, industry-oriented education only. So I think you people like industrialists definitely need to educate the students rather than be academician doing. I think you people are the right person. So thank you, sir. Thank you so much.
Practical Thank you, madam. Thank you,
Ma'am,
madam.
Subhasri ma'am,
Yes.
ma'am, tell students to fill the feedback form, ma'am.
Yeah. So the feedback link is given. The participants, please fill it up for the certificates. You will be getting your certificates. Okay. So anybody else want to tell Shar anything you can do, or we can wind up. Okay, sir. Thank you. Thanks a lot.
Yes, madam. Okay, madam. Okay,
Thank you.
bye.
Thanks.
Okay, madam. That's very good.